Hello everyone, this is Joshua Foreman, and I am here presenting Physics 2212, Lab 3, when we're dealing with circuits. Let's get right into it. So the purpose of this lab is to predict the behavior of circuits with resistors in series, as is mathematically stated in Kirchhoff's loop and node rules. Also to physically observe the cool readings from the multimeters to actually see the real-life application of the stuff we're learning in real time, and also to see how a light bulb and capacitor, how they exchange charge, and to use our models to predict and to compare that with reality, with our real-life experiment. So a lot of the stuff we're dealing with here comes from Kirchhoff rules of conservation of electrons, which involves the node rule. So that the current going into a node is the same as the current going out of a node because electrons don't just disappear. Same with potential energy. The loop rule says that the electric potential around a closed loop, the net change is zero. Both of which are very important. And when it comes to actually measuring electric potential, we have Ohm's law, which says that the electric potential equals the current times the resistance, whereas the conventional current is defined below, which can also be written as a derivative of charge with respect to time. And for capacitors, there's a different formula that says that it's proportional to charge, and the proportionality constant is 1 over the capacitance, which is just a constant that depends on the material of whatever capacitor we're using. So the main results, I wasn't exactly sure what it meant by the results, but the numbers worked out for the most part. The resistors, they said what they were, and we measured, and it did a pretty good job. And we saw that the light bulb got dimmer with the capacitor absorbing the charges from the battery. And we also saw that when the capacitor released the charges, it fed the charges back into the light bulb, which caused it to glow for actually a longer time according to our measurements, which we don't know if was actually all that accurate. So a key assumption we're making is that the resistance from wires is negligible. This is important because in order to do our mathematical tools to find different quantities, assuming resistance from wires is negligible makes the calculations a lot easier. And so our setup looks the same as it is in these diagrams, and I included a live picture to show exactly what we were doing. So the results are plotted here. We measured that the ammeters read the same initially. When we flipped the input and the output wires, it became negative, like the reading became negative. We also plotted the potential difference across different sections of the current, and looks like with our numbers, the loop rule says it adds up to 0, but for some reason we have all positive values, it looks like. But that's okay. And yeah, also with the light bulb and the capacitor, here's what we recorded. There was definitely a little bit of human error trying to figure out when the light bulb actually dimmed, because it was an exponential decay, so it's like, when do we actually count it as off? So that could account for some discrepancies in the numbers. I imagine they should be quite similar, but one is almost double the other. And so some possible sources for error was using the timer. At some point we were told that our multimeters were faulty. We also ignored resistance from the wires, which could potentially lead to slight numerical miscalculation. And, there's a lot of technology around. Maybe there was some magnetic or electric field that could have interfered with whatever we were doing. And so the what if question, if we charge the capacitor with no resistance in the circuit, if we were to just take this formula at face value, we can see that if R is 0, e to the negative t over 0 is e to the negative infinity, which is just 0. So we have delta v equals 0, and so we have no way to algebraically manipulate this equation to get something for t. But if you were to go ahead with the calculation with the natural logarithm and stuff, you would just get like zeros and infinities, and like that stuff wouldn't work out. And thank you.